Hello and welcome to the December the 1st Advent Calendar revision question. So I've chosen one from the Momentum and Impulse test that that students found quite difficult this year. It's question 12 from the test. You can see it on the screen just now. It is a Momentum and Impulse question with a force time graph, and the key to it really is to remember that momentum is a vector quantity, so direction is important. The first part of the question asks you to calculate or show by calculation that the magnitude of the impulse in the ball is 0.35 seconds. Show questions are really important. Look for that word. You have to start with an equation from the relationship sheet. So relationship. Then you have to show a substitution that's correct. And then you have to get the answer that they're looking for with units. Okay, so we're looking for impulse. We've got a force time graph. So the area in a force time graph gives you impulse. Check the units on the graph. We have milliseconds on the x-axis, which is really important because we need to change that into seconds. Okay, so the base of the triangle is 10 seconds and the altitude is 70 newtons. So impulse is equal to Ft, or area under graph, so the area is equal to a half base times height, which is equal to a half of 10 milliseconds multiplied by height. So the area is equal to, just check on your calculator, because you do want to get the answer that they give you. A little bit of a clue, and that gives you 0.35. Write it as they've asked you to write it. Newton seconds. Now they've given you the unit of impulse, so you shouldn't be getting that wrong anywhere else in the paper. Use that unit to help you in other areas of the paper that you might need impulse or change momentum. Okay, so that's part one. Part two asked you what the magnitude and direction of the change in momentum of the ball is. This is tricky. The magnitude of the change in momentum of the ball is the same as the magnitude of the impulse. So the change in momentum, delta P, is equal to 0.35 kilogram meters per second as the unit of momentum. You wouldn't be penalised if you wrote Newton seconds. The direction is tricky though. Which way is the change in momentum? Well, look at the question, because the ball is dropped from a height and it hits the force sensor. So it is travelling downwards with a velocity v, and that is the initial velocity. So let's call it u. When it hits the plate, it comes to rest. So v equals 0. So the change in momentum, it was travelling down, so momentum was down, and then it's brought to rest. So its change in momentum must be upwards, not downwards. And that's key, and there's a little bit of thought that needs to go into that. Question 3 tells you the initial speed of the ball just before it hits the force sensor. So u equals 5.6 meters per second. You have to decide which way is positive. So I'm going to say downwards is positive for the purpose of this question. Calculate the speed of the ball just as it leaves the force sensor. So change in momentum is equal to mass times final velocity, take away mass times initial velocity. I said downwards is positive. So the change in momentum was upwards. So that's minus 0.35, and the direction must be included or you'll get no marks. The mass of the ball given to you in the question is 0.05 kilograms. The final velocity you're looking for, take away the mass multiplied by the initial velocity. Now the initial velocity is 5.6 downwards, and down is positive, so it goes in as positive to the equation. So if you rearrange and solve, you get 0.05v is equal to, now this term here will go over and become an addition. So you have negative 0.35 plus 0.05 times 5.6, which gives you negative 0.07. So the final velocity is equal to negative 0.07 divided by 0.05, which is negative 1.4 meters per second. That is enough because the direction is shown. Negative means that the final velocity must be upwards because I chose down as positive. And that is crucial. And that's what makes this question particularly difficult. The direction must be considered. Okay, Cookie, as Santa strides through the snow with his candy cane, we come to part B, the last part of the question. Okay, part B asks you to sketch a graph, and it says use the same axis and sketch another graph to show how the force on the harder ball varies with time. Now, a lot of people just sketch the graph and they didn't put any values on, which is a bit silly because there's no comparison to be made if you don't put values on. So let's put the graph with the same units and the same axis, so milliseconds on the x-axis for time and newtons for force. You can either show that if it's a harder material, then it's going to have a greater force and a shorter time. Those two things you need to show. Okay, when it's a harder material. So you would have to show that this is bigger than 70, and you would have to show that this is shorter than 10. That would get you both marks. An alternative to solve this question is to show the original graph and then sketch another graph beside it. So if we show the original graph they gave us in the question, don't forget your units and your labels, we would have 70 as the force and 10 as the time. And the harder ball we would show as a dotted line having a greater average force and a shorter time. And we would label that harder material. Okay, but we did show the values and we showed how it compared to the previous ball. Okay, looking forward to tomorrow already.